So here today we are going to see exercise 5.3, that's nothing but differentiation of implicit function. So what's an implicit function here? Okay, you have it as f of x comma y here, where your y is dependent on x in this case. For example, you can have it as x squared plus y squared. So here if you see, y is said to be a function of x. Okay, so that only we call it as a implicit function in this case. So here when you differentiate this one, how do you differentiate it? Differentiation of x squared will give you what? 2x plus differentiation of y squared is nothing but 2y into dy by dx. This is what you have here. Got it? Now the first question, 2x plus 3y equal to sin x you get. So when you differentiate it with respect to x, what will you get? 2 into differentiation of x is nothing but 1 plus 3 into differentiation of y. What is it? It's nothing but dy by dx, which is equal to differentiation of sin x. What is differentiation of sin x? It's nothing but cos x. You remember why I write dy by dx? Because y is said to be dependent on x in this case. In other words, y is said to be a function of x here. Therefore, when you differentiate it, I'll have to write it as dy by dx. That's why we write it as 2 into 1. Differentiation of x is nothing but 1 plus 3 into differentiation of dy by y is nothing but dy by dx equal to sin x. When you differentiate sin x, what will you get? It's nothing but cos x. So I need only dy by dx. That's a question. So we'll just keep dy by dx to the left hand side here. 3 into dy by dx is equal to cos x. Bringing it to the other side, you will have it as cos x minus 2. So what is dy by dx equal to? Cos x minus 2 divided by 3. Okay, so here this is what you have here. So dy by dx is equal to cos x minus 2 divided by 3. Got it? Now your second question. So what's the second question you have? 2x plus 3y equal to sin y. So this is also an implicit function here. You will have to differentiate it with respect to x and find what is dy by dx. So we will see how we can find out here. When you differentiate this one, differentiation of x is what? It's nothing but 1. 2 into 1. You know how to differentiate x, no? So differentiation of x you will have here. It is equal to 1 x power 1 minus 1. That's nothing but 0, which is equal to 1. That's why I write it as 1 here, plus 3 into differentiation of y. It's nothing but dy by dx equal to sin y. When you differentiate it, what will you get here? Differentiation of sin y is nothing but cos y into y. When you differentiate it, what will you have? It's nothing but dy by dx. It's like differentiating an implicit function. Okay, sorry, not an implicit, a chain rule here. So here differentiation of sin, first of all, it is cos y. This y is also a function of x. That's why I write it as dy by dx. Now you need to find out dy by dx here. So what will you do here? Take dy by dx to the left hand side. 3 dy by dx minus cos y into dy by dx. Taking this to the other side, you will have it as minus 2. 3 dy by dx minus cos y dy by dx is equal to minus 2 you get here. Now dy by dx can be taken common. Into 3 minus cos y equal to minus 2 you have here. So what is your dy by dx equal to here? It's minus 2 divided by 3 minus cos y. Okay, when you bring it to the right hand side, you will have it as minus 2 divided by 3 minus cos y. Got it? Yes. Now your third question, okay, the same way, it is xy plus y squared equal to tan x plus y. So again it's an implicit function here. Okay, you will have to differentiate it with respect to x and find what is dy by dx. So differentiating xy plus y squared equal to tan x plus y you have. So d by dx of xy plus d by dx of y squared equal to d by dx of tan x plus d by dx of y. Okay. Now here if you see, you have x into y. What is this x into y? It's nothing but u into v. I already told you, product of two functions you have. So how do you differentiate it with respect to x here? D by dx of u into v is equal to u into dv by dx plus v into du by dx. This is what you have here. Okay, u into dv by dx plus v into du by dx. So how will you differentiate this one here? I'll have to use the product rule. So u is what? X into differentiation of y is what? Dy by dx plus y into differentiation of x. What is differentiation of x here? It's nothing but 1 plus differentiation of y squared. What is differentiation of y squared here? It is 2y into dy by dx. Okay, because you will differentiate this one with respect to what formula? D by dx of x power n, which is equal to n x power n minus 1. I will be using that formula here. So it is 2y. With that, it doesn't stop here. Y is also a function of x. Therefore, you write it as dy by dx, which is equal to d by dx of tan x. What is d by dx of tan x? Differentiation of tan x is secant squared x plus dy by dx. Okay. So your first step is to differentiate it. Now, what is the second step you will have to do here? I will have to segregate the dy by dx terms and the other terms here. So, what I am going to do here is I am going to take the dy by dx terms to the left hand side and the remaining terms to the right hand side. So, what will you get? X into dy by dx plus 2y into dy by dx. Taking this to the other side, it's minus dy by dx equal to secant squared x. When you bring this to the right hand side, it's nothing but minus y. Got it? Now, take dy by dx common. So, when you take dy by dx common, you are left with x plus 2y minus 1 equal to secant squared x minus y. This is what you have here. So, what is your dy by dx equal to? Secant squared x minus y divided by, this comes to the denominator. So, it is x plus 2y minus 1. That's all. So, here this is your dy by dx. Got it? So, here this is how you differentiate it. So, only difference is what? When you differentiate this one, you will have to be a little careful. You will have to apply the product rule here. After that, I have taken all the dy by dx terms to one side and the remaining terms to the right hand side here. Taking dy by dx common, you are left with x plus 2y minus 1 equal to secant squared x minus y. So, you will get your dy by dx equal to secant squared x minus y divided by x plus 2y minus 1. Got it? Yes. Now here the sixth question. So the sixth question is also a similar one here. So if it's a similar one, what will you get? You will have to again differentiate it with respect to x here. What is the question you have here? X cube plus x squared by plus xy squared plus y cube equal to 81. This is what you have here. Again, I'll have to find out what is dy by dx. So we'll do it step by step here. First, differentiating it with respect to x. So, how can I write here? D by dx of x cube plus d by dx of x squared by plus d by dx of xy squared plus d by dx of y squared equal to d by dx of 81. This is what you have here. Got it? So, this I can differentiate it with respect to x straight away here. Differentiation of this is what? 3x squared. What's the formula? X power n. D by dx of x power n is what? Actually, here it is equal to n x power n minus 1. So, I am using that formula here. N x power n minus 1. So, you can write it as 3x squared plus. Here again, if you see, it's uv formula. So, when you use uv formula, what will you get here? It is x squared into differentiation of this one. What is differentiation of that? It's nothing but dy by dx plus y, that's nothing but v into d by dx of x squared into d by dx of x squared you have here, plus again I'll have to use the uv formula. So when you use the uv formula, what will you get? X into d by dx of y squared plus y squared into d by dx of x. This is what you have here. Okay, plus what's the next one here? You will have to differentiate this one. 3y squared into differentiation of y will give me what? Dy by dx, which is equal to 0. You understood? I am differentiating it here. Be careful when you apply the product rule and when you differentiate y cube or y squared or anything like that. So how do I write here? It's 3x squared plus x squared dy by dx plus y into differentiation of x squared is what? 2x plus x into differentiation of this is what? Y squared 2y dy by dx. Differentiation of this is what? 2y into differentiation of y is what? Dy by dx plus y squared into differentiation of x. What is differentiation of x? That's nothing but 1 plus 3y squared dy by dx equal to 0. So what is the next step I told you after differentiation? Take all your dy by dx terms to one side. Okay, let this all be in one side. The remaining terms I'll have to take to the right hand side. So here the circle terms alone I'll keep it here. X squared into dy by dx plus 2xy into dy by dx plus 3y squared into dy by dx equal to this plus 3x squared. When you take it to the other side, it's minus 3x squared. This one, when you take it to the other side, it's minus 2xy. Here again, it's nothing but minus y squared. Now here, you can take dy by dx common here. So you are left with x squared plus 2xy plus 3y squared is equal to minus 3x squared minus 2xy minus y squared. This is what you have here. So what is your dy by dx here? This comes to the denominator. Okay. So what is your dy by dx? I told you can take it to the denominator here. So it is minus 3x squared minus 2xy minus y squared divided by x squared plus 2xy plus 3y squared. Okay. So here your dy by dx is equal to this one for the implicit function given. Got it? So till now we have seen for algebraic terms, we have seen how to differentiate it with respect to x and find out dy by dx. The next one what you are going to see here is differentiation of, what is it here? Trigonometric functions. This is what you are going to see here. So differentiation of trigonometric functions, what will you get here? Sine squared y plus cos of xy equal to k. This is what you have here. Sine squared y plus cos of xy equal to k. Now differentiating it with respect to x, what will you have? D by dx of sine squared y, okay, it's y plus d by dx of cos xy equal to d by dx of k. This is what you have here. Now you differentiate it with respect to x. When you differentiate it with respect to x, what will you get? It's 2 into sine y. I told you now how will you differentiate such term under chain rule itself. I told you just like differentiating a differentiation of x power n. It's nothing but n x power n minus 1 you get here. So it is 2 into sine y into d by dx of this one. It's nothing but sine y. What rule I have used here? It's nothing but your chain rule. Got it? Now here in this case, differentiation of cos xy. Again I'll have to use the chain rule because it is cos of xy of got. What is differentiation of cos? It's minus sine xy into d by dx of xy you get equal to differentiation of a constant, it is equal to 0. So here I have used only the chain rule what we did in the previous exercise. Got it? Now it's 2 sine y into differentiation of sine y. What is differentiation of sine y here? It is cos y into differentiation of y. What is into differentiation of y? It's nothing but dy by dx minus sine xy into differentiation of this one, differentiation of xy. So what is into differentiation of xy? You will write it as u into v here. So how will I write it in this case? Actually here it is x into dy by dx plus y into 1. Okay, remember the formula, no? What is your d by dx of u into v? What will I get here? It is equal to u into dv by dx plus v into du by dx. This is what you have here. This is the formula. So how do I write it here? X into dy by dx plus y into differentiation of x, that is equal to 0. So here we will write this as, now this 2 sine y cos y, 2 sine y cos y, you have got it here. What's the formula you get here? Actually here your sine 2a is equal to 2 sine a cos a. This is the formula. Okay, sine 2a is equal to 2 sine a cos a. You will have to remember this formula. So 2 sine y cos y will be written as what? Sine 2y into dy by dx minus multiplying it, it's x into sine xy dy by dx. Okay, now you multiply this here, it's minus y into sine xy equal to 0. Got it? Now as I told you earlier, what will you do? Take all the dy by dx terms to the left hand side and the remaining terms to the right hand side. So what will you have? Sine 2y into dy by dx minus x into sine of xy into dy by dx equal to y sine xy. This is what you have here. Now take dy by dx common here. You are left with sine 2y minus x into sine xy equal to y sine xy. This is what you have here. Got it? Now you need to know what is your dy by dx here. So that is equal to y sine xy. This comes to the denominator divided by sine 2y minus x into sine xy. This is what we have here. Got it? It's a very easy one only. Don't get startled by seeing what is it here. You have it as sine squared y plus cos xy. Just do it step by step. You will get it very easily here. Okay, so first apply the chain rule here, differentiate it. Here you will have to apply the product rule. Whenever you have y, don't forget to write it as dy by dx. That's the only thing you will have to be careful here. Okay, so here again, even if you differentiate sin y, you will have to write it as cos y into dy by dx. After that, it's just separation of terms here, dy by dx to one side and the other terms to the right hand side. Got it? Yes. Now we'll go over to the next type of problems here. Before going on to the next type of problems, you will have to just know these three formulas. It's very important here, okay, because we are going to see how we can evaluate inverse trigonometric functions here. So what's the formula you have here? Sin 2 theta equal to 2 tan theta by 1 plus tan square theta. Cos 2 theta is equal to 1 minus tan square theta by 1 plus tan square theta. Tan 3 theta is equal to 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. These are all the formulas what you have studied in your previous year. As a recalling part, I am just writing it here. You understood? So sin 2 theta, you will have to remember what is cos 2 theta and what is tan 3 theta. These are the formulas you will have to remember in this case for the next set of problems what we are going to do here. So the ninth question, y equal to sin inverse of 2x divided by 1 plus x squared. I told you the next set of problems, it's going to be slightly different, I told you there. Okay, so here inverse. So here in this case, okay, in this case it's not possible for me to differentiate it keeping it as it is. So here I will be using the substitution part actually here. So how is that I use the substitution part? If you have the denominator as 1 plus x squared, you can put x is equal to tan theta. This is one hint I can give you here. So you have 2x by 1 plus x squared. So what will you get? X is equal to tan theta is what you get. So what is your theta equal to? The inverse of this, it's nothing but tan inverse of x. So y equal to sin inverse of 2 tan theta divided by 1 plus tan square theta. Just now I told you the formula. What is it actually here? Your sin 2 theta is equal to 2 tan theta divided by 1 plus tan square theta, I told you here. So this can be replaced by sin 2 theta. So what is sin inverse of sin 2 theta? That's nothing but equal to 2 theta you get. But I need y in terms of x. Only then I can find out dy by dx. My ultimate thing is to find out what is dy by dx here. So what is your theta equal to here? Theta is equal to tan inverse of x. So I can write it as 2 into tan inverse of x. Now differentiating it with respect to x, what will I get? Dy by dx is equal to. So I hope you remember what is d by dx of tan inverse of x. What is d by dx of tan inverse of x? It's nothing but equal to 1 plus x squared, differentiation of tan inverse of x. You understood? So only thing you will have to remember here is the substitution here, and the next one you will have to remember these formulas what I mentioned earlier. 1 plus x squared, it means that your x is equal to tan theta. This is the hint I can give you for substitution. Got it? Yes. Now here the next one, y equal to tan inverse of 3x minus x cube divided by 1 minus 3x squared minus 1 by root 3 less than x less than 1 by root 3. This is what you have here. Got it? So here again I am using the substitution as x is equal to tan theta only I use here, because in this case it lies between minus 1 by root 3 less than x less than. If I use cos theta also, I will not be able to, what is it here, simplify in this case. So that is why we write it as x is equal to tan theta. Your theta is equal to tan inverse of x. Okay, so here you have it as theta equal to tan inverse of x you get here. Y equal to tan inverse of 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta you get here. So what is this formula here? It's nothing but tan 3 theta. Again I told you the formula there. Tan inverse of tan 3 theta, which is equal to 3 theta you get. So what is your theta here? Your theta is nothing but tan inverse of x you get here. Now differentiating it with respect to x, what will you get? Your dy by dx is equal to 3 divided by 1 plus x square. That is your differentiation of tan inverse of x is nothing but 1 by 1 plus x squared. The 12th question, y equal to sin inverse of 1 minus x squared divided by 1 plus x squared you have here. Again it is 0 less than x less than 1 it is given here. So as I told you, if your denominator is 1 plus x squared, what is the hint I gave you here? You can put x is equal to tan theta and theta is equal to tan inverse of x you can write here. So when I substitute it, y is equal to sine inverse of 1 minus tan square theta by 1 plus tan square theta. So what is it equal to here? It is cos 2 theta is equal to 1 minus tan square theta divided by 1 plus tan square theta you get here. So I can write it as cos 2 theta, we can write it. Okay, so here it is equal to cos 2 theta. Now this cos here, if you see, I must write this in terms of sine, only then it can get cancelled and I can write it here. So what I am going to do here is actually your sine of pi by 2 minus theta is equal to cos theta. This is the formula you have here. Sine of pi by 2 minus theta is equal to cos theta. So sine of pi by 2 minus theta is equal to cos theta means how do I write here actually here? Sine inverse of sine of pi by 2 minus 2 theta you can write it. Okay, so you will have it as pi by 2 minus 2 theta you get here. Now what is your theta here? It's tan inverse of x. Pi by 2 minus 2 tan inverse of x. When you differentiate it, what is differentiation of a constant? It is 0 minus 2 into differentiation of tan inverse of x will give you what? Minus 2 divided by 1 plus x squared. Got it? Yes. Now here the next one, 14th one, y equal to sine inverse of 2x into square root of 1 minus x squared. A slightly different one from whatever we have seen so far. One thing I'd like to tell you here is if at all you have anything as square root of 1 minus x squared, you generally use the substitution x is equal to sine theta. It's not only for here, anywhere. Okay, x is equal to sine theta we can use here. Similarly, if you have 1 plus x squared, what did I tell you actually here? Use a substitution tan theta I told you here. So 1 minus x squared, you can make it as sine theta. So here we'll see how I have written here. X is equal to sine theta. Theta is equal to sine inverse of x. Y equal to sine inverse of 2 sine theta square root of 1 minus sine square theta. What is 1 minus sine square theta? It's nothing but root of cos square theta. So here it is equal to sine inverse of 2 sine theta square root of cos square theta is nothing but cos theta. So again I told you the formula. What is 2 sine theta cos theta here? It's nothing but sine inverse of sine 2 theta. This is what you have here. Got it? So what is sine inverse of sine 2 theta? Sine inverse of sine. What is it actually here? It goes off. So here you are left only with 2 theta here. That is equal to 2 into sine inverse of x. Because what is your theta equal to here? Sine inverse of x. Now differentiating it with respect to x, what will you get here? Dy by dx is equal to 2 by square root of 1 minus x squared. So this is your differentiation of what will you get here? Y equal to sine inverse. So 2x into square root of 1 minus x squared. So if you have to differentiate inverse function like this, you will have to use such type of trigonometric substitutions and then proceed.